Okay, we're going to begin the open book test on Unit 3.1 and 3.2 of Calculus. Question 1 says, find any critical numbers of the function. Well, what is a critical number of a function? What are we talking about here? How do you find a critical number of a function? Well, critical numbers are where something is true about the derivative, right? It's where f prime of x is 0 or undefined. There we go. So we're trying to find the places where the derivative is 0 or undefined, and that creates a critical number. Now, what potentially could happen at a critical number? We could have a possible maximum, a possible minimum, and later we'll learn that there could be a possible point of inflection, which we made mention of, but we haven't dealt with yet, okay? So there's a possible maximum, minimum, or point of inflection, which are important pieces of the graph. So if we wanted to find the critical numbers, we would first find the derivative. Now, we could use the product rule, or we could distribute and make it a little bit easier on ourselves. So we're just going to change this to f of x is equal to x cubed minus 3x squared, and then take the derivative. And so we're just going to use the sum or difference rule then. So f prime of x is, in the first term, we're going to have what? 3x squared, and then minus the derivative of the difference is the difference in derivatives, minus what? 6x. So here we have the derivative. Now, if we're going to find the critical numbers, then what do we need to do? We need to set the derivative equal to 0 and solve. Now, what about undefined? How might that appear? Well, it appears if there's a sharp turn in the graph, right? So that because it's approaching something different from the left as it's approaching from the right, when it approaches something different from left and right, the limit does not exist, therefore the derivative does not exist, all that kind of stuff. A division by 0 error could also create an undefined situation. Okay? So we want to set this equal to 0, so we're going to have 3x squared minus 6x is equal to 0, and then we solve. Now, how do you solve if there's, remember, a quadratic? This is a quadratic with an a and a b, but not a c. So we do what? We factor out the greatest common factor, which is going to give us a monomial times a binomial. So we can factor out a 3x, so 3x times x would be 3x squared, and then 3x times negative 2 is negative 6x. And then at that point we set each factor equal to 0 and solve. So we're going to set each factor equal to 0. So we'll have at this point, we generally, in Algebra 1 or whatever, would say either the first factor of 3x is equal to 0 or the second factor of x minus 2 equals 0. And then we would solve each one, so we divide by 3, and we're going to have x equals 0, or add 2, x is equal to 2. So we have critical numbers at x equals 0 or x equals 2. There's a place where there's possibly, not mandatorily, there's possibly a maximum or a minimum or a point of inflection at either of those two. Any questions on number 1? So when we're talking about critical numbers, we're talking about places where there's a possible maximum, possible minimum, possible point of inflection. To find a critical number, we set the derivative equal to 0, or we try to find a place where the derivative would be undefined. Okay. Question number 2. Question number 2. We want to find the critical numbers, but it's giving us within a certain interval. We want to find any critical numbers that are within the interval of t is less than 3. Okay? All right. So the first thing we want to do is find the derivative, and to do that, we're just going to rewrite the function. So we're going to have g prime, or g of t, we're just going to rewrite that, is equal to, how would we rewrite that? T parenthesis 4 minus t to the 1/2. We need to write it in exponential form, so we change the square root to the half power. Now, what we have is a product rule and a chain rule. We have a multiplication, and we have a parenthesis. The parenthesis is a chain, and then we have the multiplication. So we'll deal with the multiplication. G prime of t would be, we're going to say the derivative of the first, right? Or, first, times the derivative of the second. First times the derivative of the second. And then the derivative of the second, you would have exponent times the guts, and then reduce the exponent by 1. So that would be to the negative 1/2. That's the derivative of the wrapper, right? And then we have to say times the derivative of the inside of that wrapper, the guts of the wrapper, which would be negative 1, right? Negative 1. So it was important that we did the chain, because we didn't just do 1, we would have got by with it, but since it's negative 1, we wasn't going to get by with it. We've only done the first part of multiplication. Here's what we've done. We've done first times derivative of second. Now we have to have what?
Second.
So what do you put in the middle? Plus, minus, times, plus, there you go. Plus, second, 4 minus t to the 1/2 times the derivative of the first, and the derivative of t is 1. Okay. Now, if we're going to set something equal to 0 and solve, that 0 thing, that whatever is set equal to 0 needs to be factors. Example, if I had t plus t squared is equal to 0, I would really need to write that as something times something equals 0. We don't like the plus. We like something times something equals 0. So we need to do some combining like terms, some kind of factoring manipulation, so that we have something times something equals 0. Now, we have an interesting phenomenon going on here. We have this little thing that looks sort of like this little thing. Now, we can actually pull out a common parenthesis 4 minus t. But what would we pull out? Will we pull out 4 minus t to the negative 1/2, 4 minus t to the positive 1/2, 4 minus t to something different than those two? And how would you even know? Well, what do you do when you don't know how to do something in math? You do something like it. You do something like it that you do know how to do in math, right? So let me re-ask that question. Let's say that I had something like 4t minus 8t to the 4th. Now, what would you pull out of that?
14.
A 14. Now, how did you know so fast to pull out the t instead of the t to the 4th, or instead of something different?
Because there's only one t and 14.
Because there's only one t here, and there's 4t to the 4th there, and you pulled out the smallest. And the reason you pulled out the smallest is because if you wrote out those factors 2 times 2 times t, and negative 1 times 2 times 2 times 2 times t, then you would have found those common factors. And the greatest common factor would have been 4t, which is going to be the least number of t's that you have. Well, so what am I going to factor out of this? The least number of 4 minus t's that I have. And the least number of 4 minus t's that I have is 4 minus t to the negative 1/2. Okay? That makes sense. I didn't want to just say that. I wanted you to see why we could say that. Okay, so we're just going to factor out a 4 minus t to the negative 1. And then that's going to be times something, which is what we want, because we need factors set equal 0. Now, let's think about this. 4t minus 1 to the negative 1/2. What's going to be left on that? Well, all that jumped, right? Negative 1/2 t. Negative 1/2 t. Now what about the second part? What's left? Well, so there's going to be a plus sign. And let me make a little bit more room there. Well, this is the cool part. This kind of works out nicely over time. What do we have to think? When you multiply with like bases, you do what?
You add the exponents.
You add the exponents. So my question is, let me do this in black. My question is, negative 1/2 plus, because when you multiply with like bases, you add the exponents, right? Plus what is equal to 1/2? You understand that's the question? This exponent plus this exponent has to be equal to that exponent. So negative 1/2 plus what is positive 1/2. What's a 1? Isn't that cool if that turned out that way? It's going to happen that way when you solve these types of problems over and over. And we kind of like that. So that's actually a t to the first, which means you don't get some crazy radical there anymore, which we like. So that's a t to the first power, which, look what else can happen. Well, let's just wait just a second to make that happen. See? And so it factors out into that. Now, we can write this. We can write this like this. We can have this factor is equal to 0. And we just kind of got to think, okay, how far do we want to go with this before we say it's going to equal 0? We could kind of, let's just go ahead and write it, maybe. So we would have this in the numerator. We can drop that and drop that. And in the numerator, we would have a, I'm just going to rewrite it. I don't want to mess people's mind up. There's a lot of stuff happening here. This is going to go to the bottom, right? So let's just rewrite that numerator for just a second. Negative 1/2 t plus 4 minus t. I'm just going to go ahead and do it like that. Then we're going to drop to the bottom the 4 minus t. That negative drops it to the bottom, and the half makes a square root. So it's going to look like that. Okay? I think I'll go ahead and write it that. I don't want to do too many steps at once. It looks like magic. And then we can combine these like terms. So negative 1/2 t and negative t is negative 3 over 2t. So we have a negative 3 over 2t plus 4 in the numerator. And we have a radical 4 minus t in the denominator. So that's really the simplified version of the derivative. We could say, well, I don't like a fraction up there, right? So if I don't like that fraction, I could multiply by 2 here, and multiply by 2 here, and I can take that fraction out of there, And that would give me a negative 3t plus 8 over 2 of those on the bottom. If we just wanted to remove that fraction in the numerator, we could just multiply the numerator and denominator by the common denominator of all the denominators in the numerator and denominator and get rid of the fraction that's there. They would look like that. Anyway, you can kind of decide how far you want to go with it. And so then what would we do now? What would we do now? Okay. If the numerator turned out to be 0, what would the derivative be? 0. If the denominator turned out to be 0, what would the derivative be? Fine. Well, either one of those is a critical point. So we need to find out whether the numerator is equal to 0 or find out whether the denominator is equal to 0. So 3t plus 8 equals 0 would be one critical number, and 2 square root of 4 minus t would be the other critical number. So we set those equal to 0. Here we solve minus 8. Negative 3t equal negative 8. Divide negative 3. And so we get t equal 8/3. So there's one critical number at 8/3. Now, over here, if t was equal to 4, right, then I would get square root of 0 is 0. So you can see that. I'll just go ahead and say that. If t is equal to 4, we would have 4 minus 4 is 0. The square root of 0 is 0. 2 times 0 is 0. But you got to remember, they gave us an interval. T is less than 3. 4 is greater than 3. It's not in the interval. So even though it would produce undefined, it's not in the given interval. So within the interval of t is less than 3, there is one critical number, 8/3. Any questions on number 2? All right. Appreciate your attention.